Hey guys, it's Dr. Jensen with CCJ 3701, Research Methods in Criminology. Sorry, that last video kind of cut me off a little bit, so I'm just going to wrap up discussing what R squared means so you know how to interpret it. Okay, so the R squared we left off in OLS regression. Remember, we were analyzing the total operating budget as our outcome variable, and we think by the predictor variable, you see it says predictor right there. The independent variable is number of actual full-time employees you have. We think knowing your employees can help us predict your budget. Okay, so how well does the model or the number of employees you have, how well does that variable do at predicting the budget? The 0.896 can literally be translated to a percent. So if you multiply this little number here by 0.986, or excuse me, 0.896, it will, change to 89%. Okay, so basically the interpretation is I can cover 89% of the variation in operating budget by knowing the number of employees an agency has. So that's a really high amount of, all the possible operating budgets that are out there. Just by knowing the employees you have, I can cover most of those. When we say we can cover most of those, it means I can explain all the different variations in the answers someone could possibly give me. Meaning it's a pretty strong predictor. The number of employees is pretty strong. It's up there almost to 1. It's almost a perfect predictor of your operating budget. Okay, but again, if we wanted to get closer to 100% or 1, we'd want to know a few more things. And that's what a lot of people do is they'll see an R squared that's kind of low, or maybe that's, okay, and they go, how could I get that even higher to predict even more? So they'll add more and more variables into their equation. Okay, what if I not only knew your employees, but I also knew the type of agency you were, or where your agency was located, or whether you were federal or state or local. I mean, that would get me a lot more coverage on being able to predict your budget. That's what R squared is. It's basically describing how much variation we can cover in that dependent variable by knowing the independents. That's it. So I can cover 89% of your operating budget by knowing that. Okay, so you've now seen me run in SPSS a regression kind of live. Here's the output for a regression. So it tells you you're running a regression, the coefficients and the outputs. We're going to look at ANOVA, we're going to look at R and the B, the slope. The dependent variable is op budget. Method is actually shorthand for using the method or the factor of an independent variable, and this is the variable I used was total full-time employees. Okay, so that's the syntax command that was run in order to get that output. Okay, so what if you are trying to predict the budget by knowing kind of categorical style stuff about an agency? Can you still run linear regression? Yes, you can, but you have to do some coding first, okay? So let's minimize this for the moment and go back into the data. So let's say we still want to predict the operating budget, and just for funners, let me show you what these operating budgets look like. Okay, so here's the op budget variable. It's on line 36. Okay, if we run a frequency of that, we go to the Analyze menu. Let me just move this up. Analyze, Descriptive Statistics, and then Frequencies. I'm going to put my cursor in here and flip it to variable names and type in OP so I can find op budget. Put it in your queue, click OK. These are all the budgets that were reported by many agencies on how, the money they get every year. Okay, look how far up it goes. And we get up into millions pretty fast, and then we actually get up into billions down here. Okay, some very large agencies, humongous agencies. That's probably a federal one down there. Okay, these are all different law enforcement agency budgets. Okay, so that's what the variable looks like by itself, and we want to know how close we get to predicting that. Let's just say we wanted to know the agency type. Okay, so if we scroll all the way up here, we have a variable called type of agency or agency type. It's on row number 4. If we go into the value labels, we can say, okay, it's sheriff's office, it's local police, it's a state law enforcement agency. They used a 1, a 3, and a 5 to be the placeholder for those categories. Okay, and let's say we just want to look at this. Let's see what's in here. Okay, and we're going to run descriptive statistics or run a frequency of it. This is what we get when we look at the type of agency, okay? So we have 841 sheriff's offices, 1,989 local police departments, and 45 state law enforcement agencies. So it looks like it wasn't federal. Actually, those really big budgets are just the state agencies, right? But they still get big budgets, okay? So it kind of shows us how many of each of those agencies we have. Well, if we want to test a variable that's nominal, we can't really do these really easy increases and decreases because you can't increase or decrease in a category, can you? I mean, it might look like you can. In some ways, you could maybe say this is ordinal, right? You could say, well, you know, you could kind of say they increase in rank or they increase in status or maybe increase in jurisdiction with what they cover or the power they have. But at the end of the day, they're all just categories, really. And you'd still have the same problem. How do you quantify or organize these in a way that I can predict the budget, okay? Because I'm still going to get that famous slope for the line that says a 1 unit increase in X amounts to such increase in Y, or the operating budget. So what's a 1 unit increase in an agency? Is it going from sheriff to local police and local police going to state? That doesn't make any sense. So when you have nominal variables, you have to recode them, okay? And in social science, we love nominal variables. We love categories. We love group membership. We love identity. So any nominal variable you have for your study that you're interested in, like maybe race or gender or some kind of status of somebody, they've been convicted, they haven't been convicted, they are in this county versus this county, or they're participating in this program or not participating, you have to take those and recode those in order to put them into a regression analysis. Okay, if you stick the variable in as is, let me show you what happens. Let's do that. Go to Analyze, and we're going to run a regression again. Linear. We have our variables that we used last time, operating budget and the number of employees you have. Now let's stick agency type in there as is. We're just going to load it into that box where it says block, where we now have two variables in there kind of stacked. Click OK. Let me show you what happens. R squared didn't move a whole lot, okay? But the interpretation is messy, okay? So down here where it says coefficients, okay? Let me just move this up a little bit so you can see. Remember, the dependent variable, we're still trying to predict the operating budget for the agency, and we still have that famous $85,000. It actually changed slightly a little bit because these little variables interact with each other when you're trying to construct the line. Okay, type of agency, what is this? Okay, so a 1 unit increase in type of agency changes the budget by what, $1 million? Okay, well that's significant, that's important. So what is a change in a type of agency? Does it go from this to that? I mean, how does that work? We have so many categories in there, we don't know what the change is. So this is why we make dummy variables, why we use zeros and ones. So we can plot this category versus that category to see if it makes a difference. So that's why we have, again, presence and absence. Having this versus not having this, does it matter? Going from 0 to 1 when you recode a variable is that 1 unit increase we need to be able to interpret this properly. Okay, so you go, well, wait a second, Jensen, there were 3 agencies in there. There was sheriff's office, there was local police, and there was state. So how do I do zeros and ones when I have 3 categories? You should actually make more than one variable out of that, okay? So when you make recoded variables in order to compare the categories against each other, you might have to do more than one recode. So we have to pick one agency that's going to be our comparison group, and the other agencies are going to be the agencies we're interested in. So maybe because the local police is the most common agency, we want to see how maybe the state agency differs from them and how the sheriff differs from them. So one of your categories has to be a 0. You have to assign somebody a 0. And then the other ones you're going to assign the 1 to. Okay, so you can make one dummy variable or one recoded variable, which would be state law enforcement agency versus police. Okay, so your state agency would be a 1, your local police would be a 0, and you can make your sheriff's office missing, so you can just kind of throw them out from the analysis. and you can make what's called a state agency variable. You could do the same with sheriffs. You could say, I'm going to make the sheriff a 1, I'm going to make local police a 0, and then I'm going to set the state guys aside to missing. So basically I can make a comparison of the sheriff's office versus the local police and see if that matters. Okay? Or you can code it like this. You can say state versus everybody else, sheriff versus everybody else. Maybe you want to do police versus everybody else. Okay? So you have to decide what comparison you want to make, because when you use 1s and 0s in SPSS, it basically tells SPSS, count these guys, but not these guys. That's how I can help you see the difference. Okay? So everyone that has a 1, you're going to count them, but everyone that has a 0, you're not going to count them. They're still going to get analyzed, but we're going to analyze the difference between counting these guys and not these guys. So just don't get confused with a 0 being the same thing as missing data. Zeros are still being analyzed. They're just being counted differently. They're being compared to. They're still very much in the variable. Missing data means you've set it aside. It's not included in the variable, and those cases are not going to be analyzed that answered that way. I often have students confuse using zeros and using missing data as the same thing. I understand why, but you can't do that because it's going to mess up your understanding of the interpretation and how these variables actually work. So a 0 is just a way of kind of shoving everybody over there, and the 1's shoving everybody over there, and then contrasting the two. That's all it really is. But again, how do we interpret this? You'd have to take that type of agency, recode it into 1s and 0s, and then, kind of plot the groups against each other, stick it back into your regression equation with the new recoded variable, and then see how it actually changes these coefficients and these significance levels and so forth. Okay? So that is why we recode. Often we have to change the organization of the variable in order for it to work properly inside a statistic. That's why we do that. Okay? So let's go ahead and show you how some of the interpretation works when we have different kinds of variables in the equation. Okay? So we're going to close SPSS for the moment and go into a document that I made that's kind of a good shortcut document. I'm going to have this for you on your course website as a kind of a shortcut, okay? And it says Understanding Linear or OLS Regression, Example 1. Okay, so it says, this one I have an interval dependent variable and I have an ordinal independent variable. So in this case, I want to know if knowing your political party predicts how much TV you watch. So the dependent variable would be the number of hours of TV you watch, and the independent variable would be what's your political party, right? Knowing this about you lets me predict that about you. Okay, so I can go ahead and put those variables into SPSS, okay, and I get, I can find out the average number of hours watched a day. I have to know how these variables are measured. I may have to recode them. I can still get an R, I can still get a B, and a constant. So this is all the SPSS output. Okay, so when I get that, I have to kind of look and see what all this means. So down here, I tell you, there is a problem with how political party is measured. So here's a little screenshot of political party. It says 0, strong Democrat, 1, not strong Democrat, 2, independent but near Democrat, 3 is independent, 4 is independent but near Republican, 5 is not strong Republican, 6 is strong Republican, and 7 is other party. So this is an ordinal variable because it talks about kind of how one way or another you're into a party, or whether you're independent or into some other party. But the way it's organized kind of makes it difficult to interpret. So we would have to recode that variable first. So down here, you could kind of eliminate if you just want to know Republican versus Democrat, basically, you could eliminate the other parties and the independents and just kind of go from like 1 to 6. And you could go from Republican to Democrat or Democrat to Republican. So that way you could say, as I increase in those numbers, I'm becoming more Republican or more Democrat or whatever. Okay. So again, you can recode stuff in so many ways. It's not even funny. But when we go back to our outcome, or our result and our output, excuse me, we have a little b, which says negative 1.129. It's right there. Okay. I'm going to actually stop here. We'll kind of go through a video together to show you some of what these pieces mean. But essentially in this document you have different kinds of variables, how to interpret different kinds of variables, and we're going to work through it in part 4.